Subscribe now.
You are welcome to today's tutorial. Today's tutorial, we are going to talk about how we can compute a linear convolution of a sequence using the DFT-IDFT method. Let's focus on today's tutorial on linear convolution. So as I said, for linear convolution, you need to do a zero padding to the necessary length if needed. So assuming that the length one, the first length or number of sample, that's what I call the length, n1 is equal to 3 here, right? And we have n2 equal to 2 here. So the number of sample that if you want the total number of sample is n1 plus n2 minus 1, right? And therefore we are going to get 3 plus 2 minus 1 equal to 4. That means the total or the final sample must be equal to 4. So if you want to perform this linear convolution using this DFT-IDFT method, we need to zero padding, because if you look at it, the lengths are not the same. So we can rewrite the length, the signal as, or the sequence as 2, 1, 2, and then 0. So 4 length, and then h of n will be equal to 1, 2, 0, 0. So now we have all the lengths to be 4. Now the same process that we passed through when we were doing the circular convolution, that the same process we are going to pass through. First of all, you can even draw your block diagram DFT to guide you, and then the next one is DFT h of n, and then here goes here. So here's what we have, and then multiplication, and then we have y of k, and after y of k you get your ID of t, and then you have our y of n. So this is what we have now. So now taking x of n, we need to find DFT of it, and then the simplest way to find the DFT is the trailing factor method, which is 1, x of 2, and then x of 3. Going into the total factor, as I said, write it without even thinking about it. Yes, j is forward, so go here, -1, -1, -1, and 1. And then the input is 2, 1, 2, and then 0. Sorry, let's 0 here. And then the final answer that you're supposed to get, you can compute it directly into your calculator, but I would like to expand it to -j minus 2 plus 0, and then plus 2 minus 1 plus 2 and minus 0, and then the last one is 2 plus j minus 2 and minus 0. So at the end of the day, this is what we are going to get as of -5, and this one summation will give us -j, because this one goes here and then and this one going to 3, and the next one also go here, cancel this, so we are going to get j. So therefore our x of k is equal to 5, -j, 3, and j. So now that we have this, we perform the same thing for h of n. So for the h of n, the same thing applies. The output is h of 0, h of 1, h of 2, and h of 3. And then it goes into the total factor 1, 2, 3, 4, 1, 2, 3, j, the forward, and the -1, -1, -1, and 1 here. So now the input is supposed to give us the input we are supposed to give us 1, 2, 0, 0. So 1, 2, 0, 0, and then at the end of the day we are going to get 1 plus 2 plus 0 plus 0. The next one is 1 minus 2j minus 0 minus plus 0. The next one is minus 1 minus 2 plus 0 minus 0. The next one is 1 plus 2j minus 0 minus 0. So at the end of the day, we are going to get something like 3, 1 minus 2j, and then also negative 1, so 1 plus 2j. That's our h of k. Therefore, we can say our h of k is equal to 3, 1 minus 2j, negative 1, 1 plus 2j. So now that we have this, we need our y of k, and it is equal to our x of k. Here's h of k. So our x of k multiplied by our h of k. So then our y of k is equal to, for the x of k, we got 5 negative j 3j, which is 5 negative j 3j, and then multiply by convolution time domains with multiplication frequency domain, which is 3, 1 minus 2j, negative 1, 1 plus 2j. And at the end of the day, we need to multiply them together to get the value that we want, and then we are going to get y of k to be equal to 5 times 3 is what, 15, and this one will give us minus 2 minus j, and this one will give us minus 3, right? Minus 3 over here, and then the other one will give us minus 2 plus j. Since the minus 2 plus j, then let's try and find our IDFT of y of k, which is equal to y of n. And therefore, using the same method, y of 0, y of 1, y of 2, y of 3, we can get equal to the total factor is 1, 1, 1, 1, 1, 1, 1, j, 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 j. And remember, it's an ID of t, so we go to the reverse back. So negative 1, negative 1, negative 1, negative 1, and 1. And then the input here, it's 15, negative 2 minus j, negative 3, negative 2 plus j. And for that matter, if you use your calculator to punch it up, you are going to get something like 1 over 4. Remember, here is 1 over 4. I forgot 1 over 4. When you multiply all this through this one, you are going to get 15 minus 2 minus j minus 3 minus 2 plus plus j, and at the end of the day, we are going to get what? 8 for the aspect. It's 1 over 4 here. And then the second one also comes to 15 minus 2j plus 1 plus 3 plus 2j plus 1. And with that one, you are going to get 20. And then here we are going to get 15 plus 2 plus j minus 3 plus 2 minus j, and that also we are going to get 16. And then the last one is 15 times plus 2j minus 1 plus 3 minus 2j minus 1. And when we add it up, we are going to get 16 as well. So at the end of the day, we are going to get our y of n to be equal to, when we divide 4 by all these ones, we are going to get the first element to be 2. 4 by 20 by 4, it's what? 5. And then 16 by 4, it's 4. And then 16 by 4, it's 4. So this is our y of n that we have been looking for. So I'll give you a trial question to try your hand on, and the question is try this question. The first question, x of n equal to 1, 2, 3, and then the next question is h of n is equal to 0.5, 0.5. So please try it and post your answer in the comment section.